Hi guys, welcome to Unit 1, Lesson 10, One-to-One Functions. We are nearing the end of the unit. We have one more lesson after this. So we are looking at a test next week. So please make sure your Delta Math is set up. A handful of you have reached out if you were having problems with it, so please do that. And make sure you get your homework done over the weekend and you hand in your quiz retake if that was something that you were choosing to do. It is due today. There are no late exceptions allowed, so make sure you get it done. All right, and please, if you have any questions about this lesson or anything at all, just send me a chat and I'll get back to you as soon as I can. 2 lessons ago, we spent time determining if a relationship was a function. And we spent time just figuring out if the x values were repeating or not. And we didn't look at the y values at all because it didn't really matter in determining if something was a function. But that is something that we are going to look at today. And they're called one-to-one functions. A special category of functions is called one-to-one. The following exercise shows the difference between a function that is one-to-one and one that is not. Exercise 1. Consider the two functions given by the equations f of x equals 2x and g of x equals x squared. So they're actually telling us right off the bat that they're functions. We don't even need to figure that out. Map the domain -2, 0, 2 using each function. Fill in the range and show the mapping arrows. So what they did here was they already, for each function, the f function and the g function, they already set up the maps and they already put the domain in for you. And they want us to figure out the range. So the first thing that I'm going to do is put the f of x function in my y equals. So I hit my y equals and I type in 2x. And then I'm going to go to my table. So second graph, and I'm going to look for the x functions that they're giving me. So -2 is here, 0, and 2. So what I'm going to write down are my y values. So I have a -4, a 0, and a 4. And now I'm going to repeat the same steps with my g of x function. So this time in my y equals, I'm putting x squared, and then I'm going to the table there and I'm looking for the same x values, -2, 0, and 2. So now I have 4, 0, 4. And the way that we usually do the maps is we don't list repeats over and over again. Now I'm going to draw the arrows to the corresponding y values. So these go straight across, right? This is going to go here. This is going to go here. But the 2 had a 4 also, so that's going to go up there. What is the difference between these two functions in terms of how the elements of this domain get mapped to the elements of the range? So what we're noticing in the first function, the f function, we're noticing that there is one output for each input. And in the g function, there is two inputs that have the same output. It's still a function, but it changes the fact that it is not a one-to-one function. So this is the formal definition of a function. Um, it's basically just saying, one x cannot equal another x, and one y cannot equal another y. In other words, the simpler definition is different inputs always give different outputs, okay? Or I like to simplify even a step further and say no repeating x's or y's. Exercise 2. Of the four tables below, one represents a relationship where y is a one-to-one function of x. Determine which it is and explain why the others are not. So the first thing we're going to do is determine if it's a function and then determine if it's one-to-one. So in example 1, I see repeating y values. So it's not a function. If it's not a function, it cannot be one-to-one if it has repeating x's. So I don't even need to look at the y's, even though I can tell that they're repeating also. So that's a no. Number 2, I don't see repeating x's. So yes, it's a function. But I do see repeating y's, so it's a function, but it's not one-to-one. In number 3, I see no repeating x's, so yes, it's a function. And I see no repeating y's either, so this is also one-to-one. So this is the one they were talking about, but I'm still going to look at the fourth one. I'm seeing repeating negative 2's, right? So this is not a function, therefore it cannot be one-to-one. On the next page, consider the following four graphs which show a relationship between the variables x and y. Circle the two graphs above that are functions. Explain how you know they are functions. All right, so take a look at all four and write down under A which ones are functions and why. I'll give you a second to do that. I am hoping that you chose graphs 1 and 4 because they pass the vertical line test. None of the x's repeat. Now, if we look at 1 and 4 for part B, we then have to determine which one is one-to-one. Well, it might be obvious to you, it might not. So I'm going to take a look at number 1. And I'm just going to sketch the best I can a horizontal line across, okay? And I'm going to, estimate a coordinate there. So the first one I'm going to say, let's, say it's 2, 4, okay? And the other one, I don't know, let's say it's negative 4, but it is horizontal to the other one, so the y value has to be the same. And I don't know if you remember, but in any parabola, aside from the vertex, every point has another point that's parallel to it. So choice 4 is one-to-one because y values do not repeat. Any line, aside from a horizontal or vertical line, is going to be one-to-one. So really what this is leading up to is the horizontal line test. So you're used to a vertical line test to test if it's a function, and now we're also going to use a horizontal line to figure out if it's one-to-one. Exercise 4. Which of the following represents the graph of a one-to-one function? So the very first thing I'm going to do is the vertical line test, the one that I'm familiar with. So number 1 is out. It does not pass the vertical line test. 2 passes the vertical line test. 3 passes the vertical line test, and so does 4. Okay. So the 2, 3, and 4 are all functions. Now we need to figure out which ones are one-to-one. So I'm going to throw, a horizontal line on this one right there, or right here, right? So this fails 4 times, right? And this fails twice. So it's definitely not number 2. Number 3 looks good, right? If I drew a couple of horizontal lines, it looks like they're only going to cross once. So I think that it's 3. But I'm also going to check 4, and 4 is a parabola, just like we just talked about, and it fails in several spots. So it is choice 3. Exercise 5. The distance that a number x lies from number 5 on a one-dimensional line is given by the function d of x equals the absolute value of x minus 5. Show by example that d of x is not a one-to-one function. So you could graph it, but if they want a specific example, um, what I'm going to do is I'm going to take a look at the graph and the table, and I'm going to see if my y's are repeating, and then I'm going to show that mathematically. So let's take a look at the graph. So this is what it looks like in the y equals. Quick little reminder, to get the absolute value is the math key. Right arrow over to NUM, and then it's number 1 where it says ABS. And then if you take a look at the graph, it definitely does not pass the horizontal line test, right? It's a V. Actually, all absolute value graphs are Vs. So I probably could pick something right off the graph, but I am going to go to my table to verify that they're repeating and to pull a nice, neat whole number off of it. So when I go to my table, I hit second graph, I did have to scroll down a little bit to see the repeating y values. So I am going to choose this and this. Notice how my ones are repeating. So I'm going to choose 4 and 6 for my example. So I said I was going to do 4 and 6. So this is just me proving, by example or algebraically, that it isn't one-to-one. So I'm going to plug in a 4, and I'm going to minus 5. 4 minus 5 is -1. Well, the absolute value of -1 is 1. And now when I plug in a 6, I'm going to do 6 minus 5. 6 minus 5 is 1. The absolute value of a positive 1 is still positive 1. So this proves that it is not 1-to-1.